So, while this question also can be answered using the percentages, the distance from the average, and other things that we discussed yesterday, I feel there's another more practical way to deal with this question. So, I'll discuss the approach, and the objective again for sharing this question is that even if, let's say, you've become comfortable with what we've been discussing since yesterday morning, it's not that now this becomes a new formulaic approach that you're just blindly using every time. Right? You should still read and understand, okay, what will probably be the best way to deal with the question. And the simpler we can make things, the better it is. So let's try doing that here also. So what's going on, first of all? If grapes are 92% water and raisins are 20% water. So what's the rest? 92% water. The rest is, guess, the solid part, the pulp part. And raisins are 20% water. How come raisins are smaller percentage water? Dry fruit, right? So maybe the water is evaporated or whatever. That's the kind of thing they're talking about. Then, how much did a quantity of raisins, which currently weighs 10 pounds? Currently, what's that about? It weighed different earlier. Let's see. How much did a quantity of raisins weigh when all the raisins were grapes? When I read this question the first time, till this point, I actually wasn't clear about what's going on. Right? I got some idea, but I didn't really understand raisins were grapes. While I know, sure, raisins are actually dried grapes only. Yet, it took me a while to process. And then this portion afterwards helped. Assume that the only difference between their raisin weight and their grape weight is water that evaporated during their transformation. All right. So what's going on? There's a grape which has a lot of water in it, 92% water, and a little bit pulp, 8% pulp. That grape shrinks. Is that smaller? Doesn't look smaller. Let's make it again. So we have a grape with a lot of water, a little bit pulp, and then that grape has shrunk, and now there's 20% water. So 80% pulp, little bit water. What has happened essentially? This water has got evaporated. The pulp has remained the same. Right? The core fruit, the pulp, that is the same. That hasn't changed at all. The only thing that has changed is the water has reduced. So a bigger grape has converted into a smaller raisin. So how are these percentages changing? Because if the pulp is the same, then how are the percentages changing? Because in the bigger grape, that pulp represents a smaller proportion, smaller percentage. The same amount of pulp in a small raisin is a much bigger share. Let's say, for example, there's 1 gram pulp, and I'm not using the percentages of the question right now. But in a grape, that 1 gram pulp is a small part. The overall grape is whatever, 10 grams or whatever. But in a raisin, which is now, let's say 1.5 or 2 grams, that 1 gram is a significantly bigger chunk. Mind you, when I took this example, 1 gram and all, I wasn't following the percentages mentioned in the question. Just processing what really is even going on before I get into solving. Just trying to understand. So now what are they telling me? That there are raisins, 10 pounds of raisins. What's the question? When these raisins were grapes, basically before evaporation, what was the weight of those grapes? So one thing anyway clear, and which is evident in the options also, it'll be more than 10 pounds. That much is anyway there. Now, how do we deal with this question? The way I see it, or the approach that I use, and I think is perhaps maybe difficult to start with, but once you get it, then it's fairly easy to implement, to execute. I'll focus on the pulp. The pulp remains the same, right? Just how the pulp remains the same in one grape to one raisin, it will remain same in those 10 pounds raisins versus initial however many grapes we might have had. So I'll focus on the pulp. How much pulp is there in 10 pounds raisins? I'll start with that. 10 pounds raisins will have 80% pulp. 80% pulp means 8 pounds. That's the pulp in the raisins. 20% is water, so 2 pounds is water, 8 pounds is raisins. 8 pounds is the pulp. Now, when we had a big bowl full of grapes, when these raisins were all grapes earlier, the weight of pulp would have been the same still. The only thing that has changed is water has evaporated. So this big bowl also has 8 pounds of pulp in it, this big bowl of grapes. And for that bowl of grapes, the pulp represents 8%. 92% is water, 8% is pulp. What's the question? What's the weight of all the grapes? So 8% is 8 pounds. 100% is how much? 100 pounds. That's the answer. I want to reiterate. While even this question, we could use the percentages, weighted average, the kind of things we did yesterday, but much more convoluted in this question. Exactly what do you take as on one side, what do you take on the other side, right? A lot of confusing things going on. So while we could answer it that way, if you can visualize the question in this way or maybe some other similar way, it becomes a lot easier to deal with, right? Another thing you could notice is that the pulp represents 8% in grapes. The same pulp represents 80% in raisins. So 8 to 80%, right? That's 10 times. So this much pulp is now 80%. And overall, that's 10 pounds. So when it is 8%, that means it will be 100 pounds. Could figure that out. More difficult. Even I went about it step by step. Focused on pulp, first figured out separately how much pulp is there in the raisins, took that into grapes, then figured out the weight of grapes. Tell me then, questions? Is it clear?
Yeah, clear. I almost used a similar method of finding out what would be the fruit content, and then what would that fruit content make the total weight of the grape.
So almost, how was it different?
हाँ मतलब same, most exactly the same.
Okay, ठीक है. Chalo, in case there are no questions, let's move on. Chalo, we'll do some drills together. So I need a volunteer. Harshan, let's start with you. Okay. So I'm going to put some numbers. Let's say, chalo, we'll start with these numbers. 10, 40, 5, 5.
Yep.
So now average will be bang in the middle.
Yep.
This one is done. Okay. What if 5 and 10? Don't need to give me the values, but just
Yep.
tell me what you can understand about the average, what sense we are getting.
That because there are more number of kids with 40 chocolates, the average will be skewed towards 40 than towards, yeah.
So therefore,
If it was, yeah, if it was 5, it would have been 25. So
Yeah.
now because it's 10 on the richer kid side, the average will be greater than 25.
right.
And that's the first sort of sense that you get from this.
For now, that's
They have excess. Yeah, they have the excess.
for now, we'll just focus on this much. We won't even get into the exact value. Excess, yes. And there are more rich kids with excess, so each rich kid doesn't need that much excess,
Yeah.
right? There are fewer poor kids with shortage, so each poor kid will be significantly short. Or mathematically, basically, this figure times this difference should be equal to this figure times this difference.
Yeah.
Anyway, if 10 is bigger, then the difference will need to be smaller. Okay. So let's now try some variations of this. Let's say I'm given, okay, 30, 60, 52. So no need for exact values, but first tell me which side will have more kids.
So the average would have been 45 because it will be more on the 60 sides, but not significantly. The difference will be smaller now than the last one.
Acha, ठीक है. I don't even remember the last value, so no need to.
Yeah, but yeah, it'll be because it's more than the middle one, it will be
Right.
skewed towards 60.
ठीक है. Let's do one thing now. 30, 60. So now let's say we know 10 kids, 15 kids, 25. So what can I say about these values? Which one will be more than 25? Which one will be less? Can I say?
The one on your right will be more than 25.
Okay. Why is that?
I mean, the weight of, actually you can't, so more kids here and less kids there, the average is 25. So number of chocolates on the 15 kid side will be,
Let me ask you this way.
yeah,
10 kids here, 15 kids here, overall average 25. Can we
yeah.
say which kids are richer, which kids are poorer? Which kids are rich, which kids are poor?
No, you
No.
just, yeah,
It could be either way.
yeah, exactly.
The point is, end of the day, they need to balance.
Yeah,
Right? So which side is richer, which side is poorer, I can't say yet.
right.
Not
Yes.
just based on how many kids are there.
Yeah,
But now, if I give you something like, for example, 30, then we
yeah.
would know that this side would be less than.
Yes.
That much we will know. But if I don't know either of the two values, then I can't just
Yeah.
say by looking at the number of kids.
Yeah.
ठीक है, that's another case. Let's try one more. So this one is given. This one is given. And this is given. Can I figure out these two?
You need either one, right?
Yeah. Because it could be just one person who's compensating for all 5 kids. It could be 5 people compensating for 5. It could be 10, anything.
Yeah. So either one will give you the other. But
yes, that's true. So if I know, for example, there's 1 kid here, then overall, tell me now, this figure more than 45 or
much higher.
45?
More than 45.
More than 45, because one person has to
compensate
for
the
these
entire
5.
Yeah.
ठीक है. Let's try one more thing. If I have 10, 20, 17, can I say anything about the number of kids?
Yeah, that the number of kids with 20 chocolates will be slightly more. If it was 15, then it would have been equal, but here it's just slightly higher than 15 than the middle point. So the ones with 20 chocolates will be slightly more than the ones with 20 chocolates.
Okay, so now let's take one step further. More or less we can tell. Can we talk about the ratio also?
Yeah.
What would be the ratio?
So you have 3 here more, you have 7 less there. Would be
So remember, shortage, excess will need to be equal.
yeah.
So
So
7
here you
times
have
number of
7.
kids. Go ahead.
7. So you have 7 shortage here,
Yeah.
and
And
you have 3 excess there.
yeah.
So it will be in a ratio of, if you do excess by shortage, it will be in a ratio of 3:7.
So which side is 3, which side is 7?
The 120 is 3 and 10 is 7.
So,
I mean,
so see, before we get into the maths of it all, starting point, let's just remember something that you already said. There'll be more kids on the 20 side, fewer kids on the 10 side.
yeah,
That much is already done.
yeah,
Right? So next, what we are trying to figure out is the ratio between the kids.
yeah,
So essentially, let's say the number of kids are K1 and K2.
yeah,
So we have 7 K1 shortage on left side, 3 K2 excess on the right side.
yeah,
These two are equal.
yeah,
So K1 divided by K2 becomes 3:7.
yeah.
3
It will be
K1
opposite.
is
Yeah,
this one. This side is 3, this side is 7.
yeah, this side is 7. Yeah,
But these are not exact numbers, right? These are
yeah. K1, K2.
ratios. So exactly how much? We don't know. 3K and 7K, right? It could be 3 kids and 7 kids. It could be 30 kids and 70 kids or what. Okay, cool. Harshin, I'll ask somebody else now. Param, up for it?
Don't think so, but yeah.
Don't think so. Kyun bhai?
No, I could not attend yesterday's session. So
Oh, acha. Acha. Fir Param, and you haven't watched the videos also?
no, I didn't get
नहीं
the
यार फिर थोड़ा मुश्किल होगा हाँ फिर you I mean keep trying to answer questions yourself but for now let me interact with somebody else then ठीक है fair Abhinav you were there both times yesterday right
Yeah.
चलो so we'll recap a question that we did yesterday. Let's say total there are 10 kids and 40 are younger with younger kids have 40 chocolates each, older kids have 60 chocolates each. ठीक है ये सब हो गया. And let's say overall, the average is 56 chocolates each. So up one by one, what can we say? Which kids are more, older or younger?
Older.
Older or more. Older का difference कम है, तो फिर each only 4 difference per kid. So we'll need more kids to compensate. Not just that. Now let's take one step further. Older or more. And how exactly will it work? Each older kid has 4 extra. Each younger kid has a shortage of 16. यहाँ तक ठीक है? So, how many older kids will we need to compensate for one younger kid?
So the excess has to be distributed between the kids.
I don't know. Did you get my question?
Can you repeat it, Anish, again?
How many older kids will we need to compensate for one younger kid? There are kids on one side. Each kid has a shortage of 16 chocolates on one side. On the other side, each kid has 4 extra chocolates. So how many such older kids will we need who have extra chocolates to compensate for one younger kid so that overall then everyone gets equal? Balance ho jaye.
4.
4 kids, right? right?
Yep.
Each kid will give 4, each kid will give 4. Overall, we'll need 4 such kids to compensate for one younger kid.
Yep.
Indeed. So, what that tells us, essentially, about what does that, rather, let me ask, what does that tell us about the ratio of older kids to younger kids?
1:4.
Older to younger.
Older to 4:1.
4. इसमें बहुत careful रहना है.
Correct.
So one thing you can try doing here, Harshin, I mentioned to Harshin also, that you separately figure out. And I asked you this earlier also, which side will be more? Who will be more, older or younger? Anyway, separately first logically figure that out. So that when it comes to ratio, even if you do tend to get confused, you can remind yourself, oh no, hold on. Anyway, older kids will be more. So how can the ratio be 1:4? Right? The
Right.
ratio of older to younger
4:4.
will be 4:1 then, not 1:4. Huh. So that's what we have here. So if the total number of kids is 10, then what's the ratio? What's the number of older and younger kids?
8 and 2.
8 and 2. Huh. Okay. So now see, this is key. Understanding that if the excess on one side per kid is 4, for example, the shortage on the other side is 16, we'll need 4 kids, 4 older kids to compensate for one younger kid. That's it. That's the ratio 4:1, which is actually what I think you only mentioned initially, right? The reverse of this.
Yeah.
So this is the ratio of the difference, and the ratio of kids will be reverse of that. Where does that come from? One way to understand is this way. We need 4 kids to compensate for one younger kid. Chalo, let's try a few more examples. Now we'll try to figure out exact values. So 10 chocolates here, 30 chocolates here. Overall, the average is 25. What can we say about the kids?
1:3.
कौन सी side पे 1?
5 and 15. 1 on the kids side.
On the left side, you mean?
Yeah, left side. Yeah.
Bigger difference here, right? So we'll need 3 people from this side to compensate for 1 person on the other side. यहाँ पे 5 का difference है, यहाँ 15 है. So 3 people will need to give chocolates to 115 person. So yeah, 1:3. But remember, this is a ratio. I don't know the exact values, but it's a ratio. But now ratio is very powerful, because now if I have to figure out, for example, let's say these are the younger kids, these are the older kids. And all I'm given, let's say, is this much. 25, 10, and 30, nothing else. Can you tell me what percentage of the kids are younger? Are they young ones? What's the percentage of young kids? Can we figure that out?
Yes.
Tell me.
25%.
Indeed, 1:3. So 1/1 plus 3, 25%. Good. And similarly, in terms of fractions, I can say 1/4. All the kids are young. Right? So ratio, percent, fractions, all basically are just different representations. So overall, now, again, I don't want you to memorize this, but one way to understand this whole thing is that overall there are 5 blanks, right, that we are dealing with in pretty much all weighted average questions. Anyway, if I have 4 of them, I can figure out the 5th. Any 4 I have, I can figure out the 5th. Also, if I have the top 3, then I can figure out the bottom ratio. I can't figure out the exact values, but I can figure out the ratio. If I have the bottom 3, then can I figure out anything about the chocolates?
No.
Let's try that again. So let's say the average is 30, 10 kids here, 15 kids here. Now?
No, you cannot.
No, now we can't, right? I don't even know who the richer kids are, who the poorer kids are. So yeah. So one thing I've understood is out of these 5 blanks, if I have 4, I can figure out the 5th. If I have the top 3, I can figure out the ratio of the bottom 2. Now, again, I don't want you guys to memorize this as a result that you just blindly apply. But I hope you've understood why it's working this way.
Yep.
Once you understand it, then it becomes really useful in a lot of questions. Many data sufficiency questions, I can directly understand this, apply this understanding. Okay, chalo, thanks, Abhinav. We'll
So
go ahead.
I just wanted to share my I mean all the learning which I had with this particular topic, right? So basically what becomes more confusing, that what exactly you have to take as a weight, and what exactly you do basically on above and the below, right? So weight per what, weight and volume. So that becomes sometimes subjective, as to we fail to decide what has to be taken as a weight and what has to be taken as a ratio.
So we saw one question
So if you
yesterday,
can,
discount wala
yeah,
question, in that we tackled
right,
exactly this issue. See, one way to think about it is that
right,
you can just try some simple numbers and try to understand what would happen if there were 2 pants, 3 pants. Would the discount percentage change? We did in that example, right? If there's a car and a pen,
yeah,
is it a simple average? Oh no, it will depend on the price, right? So you spend some
yeah,
time to try to understand that. Same thing applies
okay,
in speeds also. When I have to figure out the average speed, there what are the weights? So I get your point. That's a very valid point. So chalo, in fact, now that you've brought it up, let's do one question on speeds. 40 kilometers per hour and 60 kilometers per hour. These are 2 speeds. First question is, a person drives for 1 hour at 40 kilometers per hour and 1 hour at 60 kilometers per hour. Tell me the average speed.
Oh, 50.
Everyone okay with this? 50 kilometers per hour. Okay. Second case, 40 kilometers per hour. He drives from A to B, and 60 kilometers per hour, he drives B to A. These are 2 points. What's the distance? I'm not telling you. Now tell me the average speed.
two a plus b upon a plus b.
Okay. So don't get into the maths, but tell me, will it be exactly 50, more than 50, less than 50 kilometers per hour? Without calculations, can you tell me?
We can't say, right, Anish?
Can. Without calculations, we can say. Sure. Let me explain that. So in the first case, the average was simple average because the distance, the time for both speeds was the same, right? So now let's take a very extreme case. If let's say for 59 minutes, I've driven at 2 kilometers per hour, 59 minutes. And for 1 minute, I've driven at 60 kilometers per hour. Overall, in the 1 hour, don't calculate, don't do the maths. But overall, in 1 hour, how much distance would I have traveled? Would it be the average of 2 kilometers per hour and 60 kilometers per hour? So like 31 kilometers?
It'll be close to 2 kilometers.
Close to 2 kilometers. Because just for a very short duration, I increased my speed, right? For the longest time, I was driving at the slow speed. So, see, and you could do this mathematically also, but understand, essentially now, the weights, as we call them in weighted average, are the times. If the weight is 1 hour, 1 hour, if the weights are equal, then the average is simple average. If we are talking about 59 minutes versus 1 minute, it'll be significantly skewed towards the 59 minutes wali speed, right? And this can be visualized also if I have driven almost all the time at the slow speed and only for a fraction of the time at the faster speed. Overall, the distance covered will be much more impacted by the slow speed than what I did in that 1 minute. So how can now we apply that here? What the distance is, we don't know, but the distances are equal. So in which direction would this person have spent more time? A to B or B to A?
In which the time is more.
No, we don't know the time. We know the speed, we know A to B and B to A. That's all.
In which speed is less?
In which the speed is less, yes.
Yeah,
Right?
40.
So here they will spend more time. Why? Because he's slower. Therefore, the overall average will be more impacted by the 40 kilometers per hour than it would be by the 60 kilometers per hour, at which speed the person spending less time. Therefore, the average will be less than 50 kilometers per hour. We can actually build one step further. I wasn't planning to do this, so I haven't thought about it completely. I might be missing a step. Tell me if this is not clear. Till this point, actually, everyone okay? Kanav, clear how we can actually figure out that the average will be less than 50?
Yep.
Okay, let's take one more step now. Time more or less to ho gaya. Without calculating, remember, no calculations, no maths. Can I figure out the ratio of the times?
Yes.
What will be the ratio?
Three
Ratio
to two.
is 3:2.
Yeah,
Inverse to
60 is to 40. Right? If I'm doing 40 kilometers per hour for the same distance versus 60 kilometers per hour for the same distance, then the time will be ulta. 40 is to 60 is the speed ratio. So 60 is to 40 will be the time ratio. The time is 60K, 40K, K, yeah, chalo, M bol lete hain. Some constant, or obviously simplified to 3M and 2M. So essentially the times are in the ratio of 3:2. So now let's think of the whole problem again. I have 40 kilometers per hour, 60 kilometers per hour, and then 3. Now let's just say 3 hours versus 2 hours. Then what will be the overall average? Realize now this is actually exactly what we've been discussing so far. 3 kids, 2 kids, 40 chocolates, 60 chocolates. So overall, first of all, the average will be closer to or less than 50. Second, this difference of 20 will be split in the ratio of 3:2. Am I doing something wrong? 3:2, 20? No, okay. So 3:2, matlab 12:8. Now, average has to be less than 50. So either I can do 40 plus 8 or 60 minus 12. The average is 48 kilometers per hour. I could mathematically figure it out also, right? Assume the distance is D and then do the whole maths. Or I could realize, first of all, the weights will be the time. And secondly, if the speeds are given for the same distance, then the time will just be, the ratio of the time will just be the reverse of the speeds, right? Faster speed, less time, slower speed, more time. Not just that, if the speeds are in the ratio 40:60, the time will be in the ratio 60:40 or 3:2. And then I just use that ratio to figure out my answer.
Anish, in this one, you saying 20 kilometers that distance is being covered in the ratio of 3:2, right?
20 kilometers ka difference,
Difference. Yeah.
not distance. Like
Yeah,
40
sorry.
chocolates, 60 chocolates, the difference of 20. Hai na? Similarly,
Mm.
the difference needs to be split.
Yeah.
Did I address your query?
Yeah.
Okay, all right. So, Abhinav, coming back to your question, see, that's a very fair point that at times it does get confusing about what really the weights are. First suggestion, anyway, don't try to memorize. Here also, don't memorize. Oh, in time, speed, distance, times are the weights. No, try to understand, right? Take a simple example. For example, when the time is the same 1 hour, 1 hour, then the average is bang in the middle. So that's already indicating that maybe times, the average depends on the times. When the distance is the same, then the average is not bang in the middle. Again, tells us that distances are not the weights, right? Where the average will lie depends on the time spent at each speed. And similarly for other problems also, like we did with discounts, you can start with simpler examples to try to explain to yourself. Directly trying to solve the question can get complex. So introduce micro steps yourself to figure things out. थोड़ा समझ में आया Abhinav?
Yeah, Anish.
Sure, cool. Let's carry on. Here's a question, only one statement. I've not presented the other one. Tell me this alone, sufficient or not? Yes, no question. Yes or no? Why no, Harshin?
So material K is X and Y. We don't know what the proportion or the ratio of this X and Y is, right? But it has to add up to 10 kgs. So what I was just thinking was that even if you maximize X and minimize Y and just, you'll get two different answers. So if I do 9.9 kg of X, that will be 9.9 into 330 plus 0.05 something. So that is less than 40. But if I do the reverse, then 9.9 into 5 is 45. So I'm getting two different answers, yes and no for the less
Sorry,
than 40.
what's the other answer? This is
if X was 9.9 kg and Y was that, right?
So help. So in this case, what answer did you get in the end? Yes or no?
Yes,
So you got a yes answer for
less than 40, right? And
What do you need an answer for this question?
no, sorry, if X and Y. Yeah.
Right. So
Sorry,
in
I was
this
doing
case,
it less than 40. Yeah, sorry. So in this case, yes, X is, we get the answer to that. X is greater than Y.
okay, fine. What was the other case?
Just reverse of this. So X is, Y is 9.9 kg. And
Like that?
yes. But this is going more than 40. This is going above 40. But
Okay.
I confused it with the question of the statement.
You mixed up the two things.
Yeah, but in that one, in both, I can answer that question. So yes, it'll be sufficient.
Okay. All right. Chalo. So what I like to do many times with such questions, to start off, let's think of simple average. Basically, what would happen if things were evenly split and everything? So here, overall 10 kilograms. What if we had 5 each? So 3 into 5 plus 5 into 5. That's exactly $40. 15 plus 25. So if both were equal, then the price would be $40 of 10 kilograms of material K. Now they've told us that actually the cost of 10 kilograms is less than 40. So forget maths and everything. Real life. If actually the price is lower, what does that mean? The cheaper material is more or the more expensive material is more? Just think of it that way. The cheaper material will be more. The price is lower. Which is the cheaper material? A, which corresponds to X. So yes, is X greater than Y? We get a confirmed yes answer. So I use this quite often, right? Just real life, cheaper, more expensive, slower, faster, things like that. Plus, like I mentioned, often my starting point is, okay, let's just think if everything were even and we had a simple average. And then I go from there. Tell me, any questions here? Chalo. All right, let's continue. Here's another one. Go ahead. Chalo. All right, let's take a look. Indeed, the correct answer is C. So by the way, not needed for this data sufficiency question, but if your answer is C, can you tell me what that percentage is? What would be that value?
25%.
Okay. Okay. All right. Let's take a look. So what's the question? Each employee of a certain task force is either a manager or a director. So only two kinds of employees are there in this specific team. The question is, what percent of the employees on the task force are directors? So basically number of directors upon total members in the team. That's what I want to, that percentage I want to figure out. Okay. The first statement, the average salary of the managers is 5,000 less than the average salary of all the employees. Doesn't really help me, right? Doesn't help me figure out how many directors are there, what's the ratio of directors, nothing like that. All I know is that managers' average salary is this much less. Okay, second statement, average salary of directors is this much greater. So in the first statement, I'm learning only about the poorer people. In the second statement, I'm only learning about the richer people. How many people on the other side are compensating, we don't know. So like I mentioned earlier, basically in the first statement, I know that this difference, for example, is 5K. That's it, nothing else. In the second statement, I know that this difference is 15K, but nothing else. So then can I figure out these two figures or anything about them? No, not really. Okay, what happens when we combine? When I know both these differences, I know that on the one side, the poorer people, each person has 5,000 less. On the other side, the richer people, each person has 15,000 more. So now think about it. One rich person will be able to compensate for three poor people. Right? One rich person will be able to give 5,000, 5,000, 5,000 to three people. So overall, the ratio of the poor people, who are the poor people, the managers, to the directors becomes 3:1. So now there's one added layer here that I still don't know the number of employees on either side. But that doesn't matter because what they've asked for is a percentage. So 1/1 plus 3 times 100, 25%. The percentage I can still figure out. Had they asked me how many employees are directors, then the answer would have been E. But the percentage I can figure out. The answer to this question is indeed C. Now, one new thing you can learn through this question, or you might have already known it, but at least it became more clear for me. Oh, as long as the difference is in this ratio, 5:15, the people will be in the ratio 3:1. So that means, for example, let's say I have 60, 55, and 75, then all this will apply. Or if I had, let's say, instead of 60, I had 10, and then 5, and then 25, then also these things will apply. Right? Then also the ratio between the managers and directors will remain the same. This is interesting for me now. Right? So what really matters is the difference from the average. What the values are doesn't really matter for figuring out the ratio of the employees. Questions? Chalo, let's carry on. Go ahead, try this one then. Chalo, let's discuss. How did you find this question? Piece of cake, medium, hard, what was it like?
Little different from the other questions that we have done. I mean, not in the understanding, but the requirement, the replacement and all it. Just
A new, there's an additional complexity here.
yeah, yeah.
ठीक है, fair है. Rest of you? Because I saw quite a few answers this time. Huh? I think only one or maybe two answers. So it was taking, I think, few of you longer anyway. Chalo. So let's try to process the question. If a fraction of a 50% alcohol solution is replaced, I'll take a pause here. What are they even saying? Fraction of a 50% solution. So I have a bottle filled with a 50% alcohol solution. And then what are they saying? A fraction of that is replaced. So I'll think of it in two steps. Let's say this much fraction is poured out. And then same amount of, now let's see, replaced with 25% alcohol solution. So this much, initially this much is poured out. Then they get another alcohol solution and they pour in same amount. So again, I'm back to the original volume. But one thing I already understand is that my alcohol solution has been diluted, right? Initially, there was a stronger alcohol in it, 50% alcohol solution. This much they removed, then they added 25%, again, that much volume. Overall, I've got a weaker solution in my hand now. That's one thing. And that's evident also, resulting in a final solution with 30% alcohol. So like we discussed whiskey and water yesterday, now basically the color has become lighter than it was initially. What's the question? What is the fraction of the original solution that was replaced? So there is that added complexity here, right? It's being replaced. How do I even deal with replacement? Well, let's just go about it step by step. Let's try to do it together. So step one, I have this big solution of 50% alcohol, and I'm going to pour out some fraction. After that, I will have this much left. What fraction exactly? We don't know yet. That's what we have to figure out. But chalo, some fraction I've thrown out. I don't even need that anymore, right? I've thrown out or I've consumed it, put in another glass, whatever. Now this much is left. Now step two, I have thrown out some alcohol. Now I have to add some alcohol. So now essentially I have this 50% solution liquid, 50% alcohol solution. To that, I'm going to add a 25% alcohol solution. In what volume exactly, we don't know yet. But essentially, that's what I'm doing. That's what I'm doing. Right? Whatever I threw out or drank earlier, that's gone. That I'm not going to think about anymore for now. So now essentially we are down to a problem we've seen earlier. There's one solution with 50% alcohol, one solution with 25% alcohol. Overall, when mixed, they result in a 30% solution. So what's going on about these two? Shortage of 5 on this side, excess of 20 on the other side. So we'll need 4 from the shortage side to compensate for 1 on the excess side. So these will be in the ratio of 1:4. Right? So essentially, after mixing, I have 1 part 50% solution and 4 parts 25% solution. That's the situation. Now, what do I know? That initially a fraction of the 50% alcohol solution is replaced with 25% alcohol solution. So whatever was removed, the same volume was added. That's something I can infer from this. They haven't explicitly mentioned it, but a fraction is replaced. So 10 ml is replaced with 10 ml, or 20 is replaced with 20, or whatever. Same portion is replaced. So how much of the 25% solution got added? 4 parts. That means initially how much of the 50% solution would have been removed? 4 parts. So what was the fraction of the original solution that was replaced? In other words, how much was removed? 4 parts out of 5 were removed. As a percentage, that's 80%. So the answer is E. Tell me, questions? If it's clear, tell me in the chat. Chalo, let's continue. All right, here's another one then. Go ahead. At a certain company, a test was given to a group of men and women seeking, I'm not sure of the language here, seeking promotions. Fine. A test was given. Notice, it's not one man and one woman, it's a group of men and women. If the average score for the group overall was 80, fine. Was the average score for the women more than 85? Notice the language again. Even women are plural. There are many women, plural. That's why they're asking for an average score of the women overall. They're not asking one individual's score, women's average score. They're asking, is that average score more than 85 or not? So even before we head into the statements, let's process this a little bit. So what kind of a situation we have here? We have men, women. The overall average, they have told us, is 80. And they're asking us, is the average score of what? Of the women more than 85? That's the question. So what would that depend on? Well, right now, I don't even know whether women's average is more than 80 or less than 80. Whether women are richer or poorer. So that's anyway one thing. What would I need? Well, I would need some information about men also, some information about the number of people also, right? Okay, but I've got an understanding of, rough understanding at least of what the question's really asking. Let's look at the first statement. Statement 1 tells me that the average score for the men was less than 75. Okay. So if the average of men, and notice now 75, 85, basically difference of 5 on both sides. So if the shortage on the men's side is more than 5 per person, can I say the excess on the women's side will be more than 5 per person? No. Overall, the shortage and excess will be equal. But whether it's one person compensating for all of them or many people, I don't know. Right? For example, we could have a situation like, let's say, first of all, let's say the figure on the average on the men's side is 70, let's say, for understanding. And then on the other side, the average, for example, could be 90. And then we have equal people on both sides, let's say 10 here and 10 there. So this is one example in which, yes, the average is more than 85. Let's take another example. Again, men, women, average is 80. What's going on? So now let's say, again, average less than 75. Let's say it's 70 again. So there's a deficit of 10. And let's say there are 10 people on this side. Now, let's say here on the other side, each person is compensating for only 1 mark. So let's say here the average is 81. Can that happen? Sure, why not? On the left side, each person has a deficit of 10. On the right side, each person has extra 1. So overall, we'll need 10 times people, 100 people to compensate. But overall, we can have a situation like this. Therefore, the average can be more than 85 also. We can have a yes answer. It can be less than 85 also. So statement 1 alone is not sufficient. Okay. Let's look at statement 2 now. The group consisted of more men than women. I don't even know who's richer, who's poorer. Right? So which side is the shortage, which side is the extra? So anyway, statement 2 is not sufficient. I can't even figure out whether the average of women will be more than 80 or not. Forget 85. And it could be more than 80, it could be less than 80 also. Similarly, it could be more than 85, it could be less than 85 also. The second statement is not sufficient. Now we combine. What happens when we combine these two statements? Now, men, women, I know the overall average is 80. I know the average score for the men was less than 75. I also know now that the number of men is more than the number of women. How does that help me? Shortage of, let's say, at least 6. Shortage of 6. Let's just think of 6 specifically for a minute. Times the number of men is equal to the extra on this side, extra per person, right? The excess on each side, on the women's side, times the number of women. Excess each woman has times the number of women. Now, I know the number of men is more than the number of women. So you could figure it out algebraically, or you can maybe visualize it also. Let me just do the algebra here. Men upon women equals excess per woman upon 6, the shortage per man. Men upon women is more than 1. Therefore, excess per woman divided by 6 is more than 1. Therefore, excess per woman is more than 6. Or if you don't even take 6, you think of shortage per man. Excess per woman is more than the shortage per man. Why? Because there are more men compensating, fewer women compensating. Right? So that tells me that if this figure is less than 75, the men's average, and there are more men, then certainly the average of women will be greater than 85. I get a confirmed yes answer. The answer to this question is C. Batao, questions? Okay. Chalo. Let's do a data insights question. So this time what I need from you are 2 answers. Something like, let's say, 0.92, 0.93, or whatever else it might be. So the first for the first 2 bars and the second figure for the third bar. I'll give you time, go through the question. Chalo, let's take a look. The finesse of a gold bar. If you're still at it, let it be. Let's discuss now. What's this weird term? Finesse. The finesse of a gold bar is the weight of the gold present in the bar divided by the total weight. So if it's a gold bar, okay, there could be some impurities, right? Anyway, like they talk in terms of carats also. All right, so if it's a 100-gram gold bar, doesn't mean that all 100 grams exactly are gold only. Well, if it's all pure gold, then the finesse is, I don't know how it's expressed in decimal terms. Then the finesse would be 1. If let's say 99 grams is gold, 1 gram is impurity, then the finesse would be 0.99. That's what I've understood so far. Okay. A jeweler has 3 gold bars. Okay. The 3 bars have identical weights. Weights wise, they are equal. So let's say 1 kg, 1 or 10 grams, 10 grams, 10 grams. And the first 2 bars have identical finesse. What does that mean? That the quality of the gold bars are equal. Right? So the amount or the weight of gold inside the bar is equal for both those. All I know so far is that the finesse is identical. They haven't told me that the finesse is very high, very low, or anything like that. Just that 2 bars have the same finesse, identical finesse. Next, if all 3 bars were melted and combined into 1 bar, the finesse of the resulting bar would be 0.96. So one thing to understand here. Let's start with some examples. Let's say the 3 bars, remember, are all identical in weight, overall weight. So let's say the 3 bars are 10 grams each. 10 grams, 10 grams, 10 grams. Fine, we have 3 bars. Now, out of this 10 grams, how much is the actual gold? They're talking in terms of decimals. I can think in terms of percentages also. Like 90% is gold, 95%, 80%, 20%. I don't know yet. I don't know all that. What I do know is 2 of them have the same finesse. So the percentage of gold in these, in fact, the exact weight of gold in these would be equal. The overall weight is equal. The finesse is equal. So the weight of gold, pure gold inside these 2 will be equal. The third one will be different. I still don't know which one has more finesse, which one has less finesse. Then they're saying they melt these 3 and combine them. They make a bigger 30-gram bar, let's say. And now they have told me this 30-gram bar basically has 96% gold and the finesse is 0.96. How do you calculate finesse? The weight of gold upon weight of the full bar. So the full bar is 30. Something upon 30 is 0.96. Right? Or another way to think about it, the numerator is 96% of the denominator. If I just multiply by 100 both sides, numerator is 96% of the denominator. I can keep it as 0.96 or I could convert it to 96%. Tell me, anyone unclear about this conversion from the decimal into percentage? Basically, I'm not a big fan of decimals. If I can get rid of them, I would rather do that. 96 is easier for me to visualize than 0.96. Anyone unclear about this? Okay. Next, the question is, select a finesse for the first 2 bars and a finesse for the third bar that are jointly consistent. I noticed that all these finesses are also 0.9 something, 0.9 something. So one question that maybe could come to your mind is, hold on, we are combining 3 bars. So shouldn't the finesse be 0.3 something, 0.3 something, 0.3 something, and then you combine and you get 0.96? Or maybe not 0.3, 0.3 each, but at least some small values. No, this is where, again, we need to understand that finesse is total gold divided by total weight of the bar. So, or another way, it's a ratio, it's a percentage. So even if I'm combining 3 bars, it's still a percentage. Even if I'm looking at 1 bar, it's still a percentage. So that's why the figures for each bar separately can also be 0.9 something. It's not like these 3 figures have to add up to 0.96. That's not what's going on here. They don't need to add up. Then what exactly is happening here? If you notice, this is actually weighted averages. 2 bars have a certain percentage. 1 bar has a different percentage. Combined overall, their percentage is 96. That's what's going on here. At this point, tell me, anyone unclear how essentially we can understand that the question is about weighted averages? I haven't solved it yet. And it's not just about adding the finesse, adding the finesse, adding the finesse. It's about average of the finesses. Any questions at this point? Chalo. All right. I'm assuming that much is clear. What next? Well, one thing now, I don't know which bars are more pure. Whether the two which are identical, those are more pure, or the one which is different, that one is more pure. I don't know. So it's not like, and this is very common in data insights questions, I can't separately do the maths, calculate my values, and go and find my answer, as I still can in many problem-solving questions. Here, I have to find values that are jointly consistent with the given information. That's all. That doesn't mean these are the only possible values, right? So there's an added complexity here. It's not about calculating values. It's about finding what values out of these given are consistent. So what does consistent even mean then? Let's process that. The first two bars. So I need a value for the first two bars. Again, remember, I don't know whether the first two bars are less pure or more pure. So I can't just directly decide that, oh, first two bars will be less than 0.96 or more than 0.96. No idea. I do know, however, so now let's say we're talking about, let's call them A and B, the identical bars, and the third one is C, let's say. So the first two bars have certain finesse, the third bar has certain finesse. The overall finesse is 0.96. And the fact that the first two bars are double in weight, right? Two bars equal weight each, third bar is single. So the finesse will be, two bars will be compensating for the finesse on one side, one bar will be compensating on the other side, right? The number of bars here, because the weight is the same, because the weights are identical, that's why I can directly think of number of bars. Or I would have focused on the weight. But in this context, they mean the same thing. Those are the weights here, right? That's what will decide how much they are compensating, or how many are compensating rather. So I don't know which one is less, which one is more, but I do know that this difference versus this difference will be in the ratio of 1:2. Right? 2 bars on the left side. So 2 times difference 1 will be equal to 1 times difference 2. So difference 1 upon difference 2 will be 1:2. Right? 2 bars compensating. So the difference will be less. 1 bar compensating on the other side. So the difference will be more. Of course, those of you who did not attend yesterday's sessions might struggle with this. But I hope at least those of you who did attend yesterday's and the initial portion of today's are clear about how I got till here. Yeah, okay. So what next? Now, this is what I need to keep in mind, that the 2 bars will be closer to 296. The 1 bar will be farther from 96 and twice as far. So already in my mind, I'm thinking it could be something like, let's say 95 on one side and 97 on the other side. Difference of 1 on one side and difference of 2 on the other side. Of course, it could also be difference of 2 versus difference of 4, or difference of 4 versus difference of 2. Exactly how it's going to pan out, I don't know. But this much I have processed, that the differences on 2 sides will be in the ratio of 1:2. Which one is more, which one is less, I don't know yet. So then I go through the numbers. 92, and again in my mind, I'm not even focusing on the decimals. 92. Okay, if 92 is the first 2 bars, basically a difference of 4, then for the other side, the difference will need to be 8. Anyway, 96 plus 8, the finesse can't be more than 1. So anyway, the first 2 bars can't have a finesse of 92. That much is done. Okay, can the first 2 bars have a finesse of 93? 93 and then 99. That's the highest value. Even they don't match, because if the shortage is of 3 per bar, overall the excess would need to be of 6. So that takes us to 102. Not sensible. First 2 bars, 94. That's a shortage of 2 each. So on the other side, the excess should be of 4 overall. That means at 1 is not there in the options, gone. Okay, now I'm in the excess territory, and that's okay. So if the first 2 bars have a finesse of 98, in other words, 2 excess each, overall excess of 4, that excess of 4 will need to be compensated by the third bar. There's only one third bar, so the shortage on the other side will need to be of 4. So this one fits, because if the excess is of 2 each, the shortage will be of 4. And I have that value in here. 92 is there. These two match. Now, once I've found a pair that matches, there's no way there can be another pair also that matches. They won't give us there won't be 2 separate correct pairs of answers. But still, for our practice, let's still look at 99 also. If the first 2 bars have 3 excess each, overall the excess becomes 6. On the other side, the shortage will need to be of 6. Only 1 bar will be responsible for the shortage. So the other side should then be 90. The third bar finesse should be 0.9. That's not even an option. So gone. Again confirmed, this is the only pair. A key part of how you deal with data insights questions also is how you structure the problem, right? How you process it, how you understand it, that's one part. And then how do you deal with exactly the box? Notice here, for example, and this is not necessarily the only way or the best way, but still, I had a structure. I was just focusing on the first column and correspondingly trying to figure out if the other values, if the value for the third bar is present in here or not. Right? So I just went through 5 in the first column, and correspondingly, I figured out which pair matches. I was done. Right? I wasn't going about both values at the same time. I wasn't looking at 0.92 for the first 2 bars, then 0.92 for the third bar, which maybe could also be an approach. I'm not saying that that's not definitely wrong. I don't know. But I had a structure that I followed. It wasn't just random. I had put thought into how I should approach the box. Chalo. So the answer here is 0.98 for the first 2 bars, 0.92 for the third bar. Tell me, questions?
Even though I arrived at the correct answer, I think the way I did it was incorrect. I just luckily arrived at the correct answer. I thought I filled 0.96 and 2 in 1, I was there. But I then thought that, because there are 2 here, then the finesse of the both will be more than 96 and the third will be much lesser. I just plugged in 98 and 90 out. So I was lucky that way. Yeah, I didn't realize that even after that, you can't say that the finesse will be more or less.
If you recall, that's when we were discussing that drill earlier, that's the mistake you made there also. And just by knowing which side has more kids, I can't say which side is richer.
Yeah.
Same issue here. Any other questions, comments? How's it going for the new joinees? Param and Remy, how are you finding it so far?
Anish, I just want to ask one question.
Let me now ask them, and then.
Yeah.
Yes, Anish, I was able to understand aspects of it, but I have to revisit yesterday evening's session then I can connect the dots.
So anyway, Chalo, now that we're on this topic, so when you do go back, revisit the first 2 sessions, after that, come back to this session also. And don't assume that this one is done anyway. I just need to do the previous ones.
Yeah. It's not a task. I mean, I will sit and and go through all three of them and then consciously try to learn.
ठीक. Remy, similar situation. Parts of it. ठीक है. बताओ कनफ.
Just want to check that if the options were not given in this question, then we wouldn't have been able to get this answer, right?
Absolutely right. Yes. There's no fixed values we can give.
Because then the answers would have been infinite, right? Like if we only knew that there are two is to one, and then the average is given, but then the finesse of the 2 bars and the 1 bar would be multiple options.
You're right. So actually, let's try that exercise now that you mention it, and others can also pitch in. Let's say these are the values of the first 2 bars. And then correspondingly, what would be the finesse of the third bar? Let's try to figure that out. So if the finesse of the first 2 bars is 92, then what would be the finesse of the third bar? Enough?
4 and 4, so 1.04.
Something more than 1.
Yeah.
Right? Which anyway doesn't make sense. Realize the weight of gold in the whole bar can't be more than the weight of the bar itself.
Yeah.
Right? So this one anyway doesn't make sense for the first 2 bars. With me till
Yeah.
here?
Yeah.
Let's try the second one.
6. So 1.02, again more than 1.
Issue. ठीक है. Third one.
94 and 1. So 1.
Right. Which is okay. Maybe we can have pure gold. Right. So
Yeah.
yes. So this is another. Had there been a 1 in here, that 0.94 and 1 could have matched. 0.98 तो हमने already कर ही लिया. 0.99.
Yeah. 0.99 also, yeah, 90 for the third.
3 excess per bar, overall 2 bars, so excess of 6, which will be compensated
so
on
90.
the other side. Other side will become 0.9.
Yeah.
You're right. And plus realize now we started with first 2 bars. I could instead start with third bars. So just with these 5 figures, maybe I can get so many different combinations, so many different pairs. Plus, if I don't even have these numbers, then anyway, the finesses could be many different things.
Yeah. Yeah.
Valid point. ठीक है. Chalo. Let's do one more. Before that, quick recap. This kind of thing we've already seen. If one solution has 25% alcohol, one solution has 33% alcohol. When they are mixed, then what percentage alcohol will be there in the mixture? Somewhere in the middle. Right? This we discussed yesterday. Exactly how much will depend on in what ratio they are mixed. So instead of percentages, if we had fractions, then how would it work? If I said the first solution has 1/4 or 1/4 alcohol, the second solution has 1/3 alcohol. And then we mix these two solutions. Then also the same thing will hold true. Realize fractions and percentages essentially are different ways of just expressing the same thing. When I mix those two, the overall percentage will be somewhere in the middle of 25 and 33 and a third. Similarly, if I'm actually doing the same thing, but just thinking in terms of fractions, then also the alcohol in this resulting solution will be in this range between 1/4 and 1/3. So essentially, the same problem can be framed in different ways, but it still means the same thing. So whether dealing with percentages or fractions, essentially we're dealing with the same thing. So we're going to do another question now, in which potentially you will use this. So I wanted to just at least share this much with you even before you start the question. Try this one. Notice I've added this word in brackets. Actually, the original question did not have the word fed in there, which I have seen leads to some confusion in some people. So I've added in there. Anyway, the original question also meant the same thing only, but I've just added it for clarity. It is an official question. So include the word fed, right? These are the statements. Go ahead. Let's discuss. How was it? Easy, medium, hard?
Hard.
Rest of you?
Yeah.
I mean,
And what made it hard for you? What were you finding hard?
Many things, because if you read it very apparently, you know that you automatically get towards E, that how many pigs, that doesn't is not answered in both these statements.
But then maybe the answer
That
is E, no?
uh yeah, that's one thing. But when you think, then after that, I actually thought, okay, let me just solve it to see what all is there. Then I started making some equations, and then also I was getting multiple answers. So then I thought, okay, multiple answers again is E. Then I reread the question and said that when we apply the half pound exactly, then I thought that, okay, maybe the answer should be divisible by 5 also. I mean, sorry, the answer should be that it should be divisible, that everybody gets half pound exact. So the other options were not exactly splitting to half pound each.
Hmm. Hmm.
So then that's how I got a unique answer, but it was pretty tricky.
Yeah, no doubt. Yeah, fair point. On GMAT Club, this is a 95% difficulty question, highest difficulty, 800 plus level. So no doubt it's a fairly difficult question. So anyway, the expectation wasn't that you guys will be able to solve it. I didn't expect that. The risk now is maybe even after we discuss, maybe you will still not be crystal clear about it. But still, I thought, chalo, ek try karte hain. Let's try a super hard question together. All right, chalo. Let's look at it now. Each piglet in a litter is fed exactly 1/2 pound of a mixture of oats and barley. Exactly 1/2 pound. So they are all fed equal weight of this mixture. The ratio of the amount of barley to that of oats. What does that mean? Ratio of amount of barley to that of oats varies from piglet to piglet. Okay. So each piglet is getting 1/2 pound, but within that 1/2 pound, how much is oats, how much is barley? That varies. So it's not a homogeneous mixture, right? Some pigs might get, or some piglets might get more oats, less barley, more barley, less oats. That too, exactly how much more, how much less, that can vary. So I'm imagining that it's like these two grains have been combined in one big box, and they have like a 1/2 pound scoop, and somebody's just feeding them with a 1/2 pound scoop. But exactly in the mixture, are the two equally distributed, the two grains? No, they have mentioned. It varies from piglet to piglet. But each piglet is fed some of both grains. Okay. So it's not that, array, some piglets are getting pure oats, some piglets are getting pure barley. They are all getting oats and barley both. Exactly in what ratio, we don't know. What we do know also, though, is that every piglet is getting exactly 1/2 pound. By the way, 1/2 That's another way of saying a half pound, right? 1/2 means half only. It's not 1.5. It's not 1.5. It's 1/2, a half. So 0.5 pounds. Each piglet is fed some of both grains. How many piglets are there in the litter? We have to find the number of piglets. Okay. Fine. So far, I don't see a lot that can be processed in the question. Right? So not a lot that I can maybe simplify or figure out before I head into the statements. Since there isn't much like that, I'll move on to the statements. Piglet A was fed exactly 1/4 of the oats fed today. So overall, basically all the pigs combined, let's say they were fed, I don't know, 400 grams of oats or whatever that figure is. Out of that, 1/4 was fed to piglet A. Now, the question is, how many piglets are there in the litter? Anyway, I don't even know whether each, or rather, I know that each piglet was not fed the same ratio. So it's not like if the first piglet was fed 1/4, then the second piglet was also fed 1/4, third was also fed 1/4. That's not the case. So is it possible, for example, piglet A was fed 1/4 of the oats, and then the second piglet gets 3/4 of the oats, which could still be within half a pound? Yeah, that's possible. Or maybe 3 or 6 or 8 piglets could have been fed, right? So using statement 1 alone, I can't figure out the number of piglets. I do understand one thing, that if a piglet A was fed 1/4 of the oats, that means somebody else was fed, at least one more piglet would have been there, so that remaining 3/4 can be consumed. This much I know. So the number of piglets will be more than 2, greater than equal to 2. What number, I don't know, but chalo. So statement 1 alone not sufficient. Statement 2 alone, piglet A was fed exactly 1/6 of the barley fed today. Same piglet, by the way, which we'll use later, was fed exactly 1/6 of the barley. Again, we are given that the ratio of oats to barley for each piglet is not the same. So if the first one was fed 1/6, doesn't mean the second one was also fed 1/6 and so on. I don't know. Is it possible that the first one was fed 1/6 and then second one was fed 5/6? Yeah, that's possible. Maybe overall barley is anyway close to half a pound. Who knows? Or is it possible that there's a lot of barley and each one is fed small proportion, basically 1/6 maybe represents 0.4 pounds. Is that possible? Yeah, that's also possible. So again, I can't figure out the number of piglets through the second statement also. That much is done. The two statements alone are not sufficient. Now the only thing remains is whether the combination is sufficient or not. So let's look at that now. Piglet A was fed exactly 1/4 of the oats, and the same piglet was fed exactly half of the barley today. So let's try to figure out a few more things. Let's say the answer is not directly jumping at us. Let's try to process as much as we can. Using the first statement first. Piglet A was fed exactly 1/4 of the oats. So, let's say almost. Entirety can't be one grain only, but let's say almost all the grain that was fed to piglet A was oats only. Let's say almost all. So then 1/4 is close to half a pound. And then overall would become close to 2 pounds. But can the overall oats be equal to or more than 2 pounds? No. Overall oats, and I'll explain this again, overall oats will be less than 2 pounds. How did I get there? Each piglet is fed exactly half a pound. I'm saying that let's say this 1/4 represents almost complete oats, which is, realize the upper limit. Basically, let's say this 1/4 is close to 0.49 pounds, let's say. So then the overall 0.49 times 4 will be the total weight of oats, which is still less than 2 only. On the other extreme, if anyway 1/4 represents, let's say, 0.1 pound, then overall total will be 0.1 into 4, 0.4, which is anyway smaller. So one thing at least I've figured out is that the weight of oats anyway will be less than 2 pounds. By the same logic, using the second statement now, the weight of barley. Let's say the first piglet A was almost entirely fed barley only. So let's say this is 0.49 pounds. Times 6 for the complete weight of barley would still be less than 3 pounds. 0.5 into 6 would have been exactly 3. This is definitely something less than 0.5, because remember, each piglet was fed both these things. Each piglet is fed some of both grains. Also, to make sure we're on the same page, if the weight of barley fed to piglet A was small, let's say 0.1 pound, then overall the weight of barley times 6 would be just 0.6 pounds. So this thing still holds, that the weight of barley will remain less than 3 pounds. Oats less than 2 pounds, barley less than 3 pounds. So overall, the total grain is less than 5 pounds. This much I've got. Does this give me the answer? I know that each piglet is fed exactly half a pound. Okay, so less than 5. That means overall, the weight of grain has to be a multiple of 0.5. 1 pound, 1.5, 2, 2.5, something like that. So less than 5 pounds means that it could, for example, be 4.5 pounds, 4 pounds or something. So which could translate into 9 piglets, 8 piglets, and so on. So while I did figure something out, it didn't help me get to the answer. Not yet anyway. I'll have to think more about it. So now I want to focus on that half a pound again. Overall half pound, and 1/4 is oats, 1/6 is barley. So I have a question for you. Is it possible that whatever this total grain is, right, whatever they have in their feeding basket, is it possible that piglet A got, let's say, half of total grains? Let's just start with this. Is this possible? That overall piglet A got half of the total grains. Remember, piglet A was fed 1/4 of the oats, 1/6 of the barley. So could these have added up to overall half? No way.
It would be between 1/4 and 1/6.
Yes, you're right. You're right. That's where I'm going. No way it could be half. Because then that would mean that if I just do twice, then overall I get the full capacity. But then 1/4 of oats plus 1/6 of barley times 2 will not give me full. This will still be fraction only. Half of oats plus 1/3 of barley, that's not full. So anyway, then I'm noticing here, piglet A can't be fed half of the total grains. Has to be fed less than half. Why did I take half? I took some easy fraction to see what's really going on here. Now let's take another extreme, the other side. Could piglet A have been fed overall 1/10? let's say. Could piglet A have been fed 1/10 of the total grain? Let's understand that. Remember, it was fed 1/4 of oats, 1/6 of barley. So if piglet A overall, that half a pound represents 1/10, then overall for all pigs combined, 1/4 of oats plus 1/6 of barley, this is half a pound. This much we know. If that represents 1/10 of the total grain, that means this thing times 10 will be the full weight. But when I multiply by 10, I get 10 by 4, 5 by 2 of oats plus 5 by 3 of barley. This doesn't make sense. The full weight anyway will be oats plus barley only. Right? Total oats plus total barley, that'll be the full weight. I can't have 5 by 2 oats. That doesn't make sense. Right? Full oats plus full barley will be the total weight. So I am onto something. O represents the total weight of oats. B represents the total weight of barley. Also, now although I am working with variables and equations, but I don't want you to think about it algebraically. While you can, let's just try to visualize this. So if piglet A were fed half of the total weight, then there's oats and barley left out. But remember, piglet A was fed 1/4 of all the total oats fed today. So there should not be any oats left. There should not be any barley left. If piglet A were served 1/10 of the total grain, then that means that there needs to be extra oats and extra barley. 1/4 and 1/6 are not enough. That also can't be the case. So, what can I say about how much piglet A was fed? Let's try one more thing now. Could piglet A have been fed 1/4 of the total grains? As far as oats are concerned, that looks decent. Haan, theek hai. 1/4 goes to piglet A, 1/4, even if let's say it's evenly spread or however. For oats, it's okay. But overall, if piglet A is fed 1/4 of the total grains, then there'll be barley left over, which is not fed to anyone. I'll show you mathematically. Piglet A is fed 1/4 of the oats plus 1/6 of the barley. And if times 4 equals the full, which is oats plus barley, there's a mismatch. Notice 1/4 of oats plus 1/6 of barley times 4. This becomes oats plus 4/6 of barley. How can that be equal to oats plus full barley? There's a mismatch. So I also learned that piglet A couldn't have been served 1/4. Could piglet A have been served 1/6? No, same issue or a similar issue will come again. 6 into 1/4 of oats plus 1/6 of barley becomes 6 by 4 of oats plus barley. This can't be equal to oats plus barley. Right? 6/4 of oats is not equal to oats. So what's left then? And remember, what is this fraction that we are talking about? Actually, I'll get to that in the second step. What's left? What I can understand is that piglet A was served a fraction between 1/4 and 1/6 in this range. Actually, I should write 1/6 by 1/4. 1/6 to 1/4. 1/6 is the smaller one. Anyway, same thing still. This is the range of how much grain or what fraction of the grain was served to piglet A. Next now. Could the fraction be something like 1 point, for example, 4.5? Could the fraction of grain served to piglet A be some weird fraction like this? It can't. Let me explain why. Remember, each piglet is served equal weight, half a pound each. The number of piglets anyway will be an integer. So each piglet will be served, let's say if there are 5 pigs, then each piglet will be served 1/5. If there are 6 piglets, then each would have been served 1/6, 1/4, 1/8, 1/9, whatever. It will be a fraction with an integer in the denominator and 1 in the numerator only for each piglet. So, could piglet A be served 1/4.5 of the total grain? No, it has to be 1 upon an integer. Could it be 1/9? No, it has to be between 1/4 and 1/6. So, what in this range, I need 1 upon integer. What can this integer be?
5.
Only 5. So that means within this range, it has to be 1/5. Piglet A was served 1/5 of the total grain. That means total, how many piglets are there? 5 piglets. Has to be 5 piglets, right? If it was served 1/4 of the oats and 1/6 of the barley, overall, it definitely was served 1/5 of the total grain, as we figured out earlier. And therefore, how many piglets are there? Has to be 5. The answer to this super difficult question is C. I will elaborate on that algebra a bit more. Just to understand, maybe this 1/4 between 1/4, 1/5 was difficult to follow. I will elaborate on this a bit more. So,
Yeah, Anish, I have a question.
let me finish. Let
Oh.
me take this other approach, then we'll discuss. So, oats, barley. Now, piglet A is fed 1/4 of the oats and is fed 1/6 of the barley. Now, let's say there were total 4 piglets. Then the question is, will 4 piglets use up all the grain? Realize now, let's say, and remember, 1/4 oats plus 1/4 barley is equal to 0.5 grams, right? That much is there. So essentially, for 4 piglets, the overall weight would need to be 2 pounds. I think I said grams earlier, 0.5 pounds. So for 4 piglets, the overall weight would need to be 2 pounds. The weight of grain. I'm just taking a number, 4. So, and also, let's say if there were actually 4 piglets, they would use up all the oats and all the barley. In other words, oats plus barley would need to be 2 pounds if there are 4 piglets. But now, if I just multiply A's grain by 4, that should also be 2 pounds. In other words, 4 into 1/4 O, which is essentially O, plus 4 into 1/6 B. This whole thing should also be 2 pounds. The weight of the food consumed by the first piglet times 4 will be 2 pounds. But what do we get here even? O plus 2/3B, 2/3B. Some barley essentially is left over. Right? So this way also I can understand that, hold on. The piglets, if there are only 4 piglets, they're not consuming all the food. If there are more than 6 or more piglets, then they'll be consuming extra food that they don't even have. The only situation in which they can consume all the food if there are exactly 5 piglets. With any figure less than 4, there'll be grain left. With any figure greater than equal to 6, they'll need more grain. This much grain won't be enough. If I multiplied by 6, for example, I would get barley plus 6/4 of oats. Again, excess oats. I don't have that. Can I explain this without the equations? I'm not sure how to visually represent it. Give me a second. Okay, let me try. So let's say this is 1/4 of the oats, and this is 1/6 of the barley. So let's say for a second that there are 4 piglets and they're all given. They're anyway given the same weight. Even if the ratio is the same for 3 other piglets, overall the oats will be all used up. But the barley will still be left. And this is when I have 4 piglets. If I have, let's say, 6 piglets, then overall the barley will be all used up, but the oats will go beyond. This much I don't even have. Now, I know that the ratio for each piglet is not the same, but the weight is the same, right? Even if the ratio varies, overall everyone gets half a pound. That's the thing I'm using really. With 4 piglets, overall that would mean 2 pounds. With 2 pounds and this ratio given, overall things are not adding up. 6 piglets overall means 3 pounds. Again, things not adding up. Only situation in which things would add up is when the overall grain is 2.5 pounds or the number of piglets is 5. Ab batao. Questions? Somebody had a question earlier.
Yeah, hi. Yeah, Anish, I was just writing to you that I have to leave actually. So if there is any more left, I'll have to watch the
Nahin,
video to.
we've already significantly run out of time.
Yeah, that's why I had to just be somewhere. I don't know. It will take a while. I guess I'll just work on it again. I got the part where first it was giving me multiple options. Then I thought that okay, if the criteria that everybody needs to get a half a pound, then you only get 5. But I just used like one equation rather than these 4 or 6 or 10 or 2 uh, this thing.
Yeah.
But I think I'll have to I'll have to
Hmm.
but just thinking in very short time that is this a reasonable method that I mean I just thought of it right now that 1/4 means 25% and 1/6 means 16%. That means uh the no I don't think so that we can't say right that the average will be in the middle of these two.
It will be. It
It
will be.
will be.
That's how 1/5.
Yeah.
1/5 is that only. It will be
But
20%.
yeah, then can we say that no other number is such between 25 and 16.25% and 16.66% that you multiply by an integer, it will reach to 100.
You're right. You're right. Basic funda is the same, right? Which I discussed in fractions, you're discussing in percentages. But the point, one of the complications here is we are used to dealing with such questions when we are talking about alcohol and alcohol, ryegrass and ryegrass, right? Here there's oats on one side, barley on the other side, yet we are applying the same principle.
Yeah.
That's the true complication. Apart from that, what you're saying is absolutely right. The same thing applies even when I'm looking at just these fractions. Between this, when would I need 1 upon integer, right? Which is another way of saying that the percentage times an integer should be 100.
Yeah.
So when can that happen? Only for 1/5. So that basic funda is the same. That either you think about 16 कितना होता है 16 point
16, 17 somewhere in the middle.
16.67% and 25%. So the only situation in the middle is 20%. Yeah, you could think
Yeah,
of
and
that also.
I just made like different some cases as well of what would be the quantity of oats and what would be the quantity of barley, uh, different combinations where each one. So now only one number was there which was divisible by any of the integers. All the other numbers were not coming, like none of the other all the other numbers totals were fractions.
I'm not able to follow like this kind of.
That's fine. That's okay. That's okay.
Take. Stick around for
Not
a
an
couple
issue.
of minutes if you can. We'll just discuss takeaways after this.
I have to leave. I'm really sorry.
That's fine. No
I
worries.
I can send you an email about the takeaways, at least from my side, or my feedback. I'll surely do so. I'm really sorry.
All right, that's fine.
Thank you.
Chalo.
Thanks a lot.
You're
Thanks a
welcome.
lot. I'll look on LinkedIn for any future opportunities that are there for. Yeah. Thank you very much. Thanks.
My pleasure. Baaki log batao. Questions?
I did a slightly different one. I don't know if that was the correct way of thinking, but you tell me. So up until the point of between 16.6 to 25, that I was clear. Then I just thought that there are 10 total parts of grain. So 4 and 6.
Sorry, 10 what?
Total parts of grain. You don't know the total weight, but basically, because he was fed 1/4 and so 10 total parts of grain.
I
This
don't know what
piglet
this, what do you mean by 10 total parts? I didn't get that.
I mean, I thought that the weight of the total. Why I went down the weight part is because it was given 1/2 pound and everyone is given the same. So
ये
I
तो पढ़
thought if
लेते
I
हैं ना.
can.
Let's say, for example, let's talk in terms of weights.
Huh,
So we have 1/4 oats, 1/6 barley.
yeah,
So let's say 1/4 oats means whatever, 100 grams out of 400, something like that. Actually,
yeah, yeah.
grams, arey yaar, we are dealing with half a pound now.
So okay, 100 pounds out of 400 pounds.
0.1,
Yeah, same thing.
0.4 pound.
Yeah,
Okay. And then the 1/6 correspondingly would have to become 0.4 pound.
yeah,
right?
yeah.
1/6 represents 0.4. So overall, this would be 2.4.
Yeah.
हाँ, अब बताओ.
So then what I thought was कि okay, if there are 10 parts of the total weight of the grain, this pig is fed 2 parts out of it because he is basically fed one of each. I did it.
10, repeat this, 10 parts. What is this
So
10 parts? I'm still not getting that. Tell me in terms of
basically,
pounds.
out of the total grain, there is some mixture of oats and grains which we don't. Out of that total mixture of oats, he is fed 1/4, and out of the total ratio of barley, 1/6, right? So whatever the total weight is, he's fed 10. Out of the total 10 parts, he's fed 2, which correspond.
This is where you're making a mistake. You can't just equate the parts of oats with parts of barley and then combine them to say there are 10 parts.
Okay.
Anna, I don't know. Basically, that would happen if 1/4 of oats is basically, let's say 4 parts means, let's say 40 grams and 6 parts means 60 grams. Then you could combine and say, okay, overall 100 grams and he's fed 2 or 20 grams. Anna? But here we have
even if it's a different ratio out of X number of total parts, that will be 1/4 and 1/6 of that, right? That's why because they're all fed equal amounts, half.
Let's take an example. Let's say,
there's 50 pounds.
There are two glasses with liquids.
Yeah.
And then you put 1/4 of this glass in another one. Okay, 1/4 comes out. And 1/6 of this glass comes out. Both get added to the same glass.
Yeah.
So are you saying then this glass is 2/10 filled?
Yeah.
Would that not depend on the volumes here?
That's what that's what I thought I'm doing wrong. That's why I just wanted to confirm this approach with you. I'm basically I thought the ratio because we don't know. So I thought in terms of parts, and because the crucial piece was that for each of the pig, the weight is the same. So pig A is fed 2 out of 10, which is half pound. So the total weight of all the pigs is 2.5. So 2.5 upon half, that means I'll have only 5 pigs. That's why I got the answer as 5, but I'm not sure if it was the right approach.
Wait, there's a mistake there. Nah? We can't directly assume that. I mean, while it ends up being that, but just from these
Yeah.
two things, we can't directly infer that he was fed 2 parts out of 10.
Yeah, effective. Why I went down this road was because I thought कि okay, half pound दिया है and वो same है. So let me think in terms of grams, and if I'm able to arrive at per gram wala, I will be at the I'll end. But I understand this N approach also. I think that was a little bit easier. 1/4, फिर 16 से 25 के बीच में एक ही ratio होगा जो whole number पे जाएगा. So that was 20% also. So I thought that was more intuitive the second way. Yeah.
ठीक है, चलो, fairly difficult question this one anyway, है ना? तो थोड़ा
Yeah.
बहुत समझ में आ गया तो that's plenty for today.
No, yeah, this was a good one out of all the ones that we did. It is difficult to think that this is also weighted average question but yeah, that what helped was when you said before this, when you gave that hint, na, ki it will always be in that range. That's what I immediately was able to apply कि वो 16 से 25 के बीच होगा. So yeah.
ठीक है, चलो, it's just you and me now. बताओ, how was your experience these last?
No, it was great. I think like I was telling you, all of this is forced and again to not apply the formula. I think for some of these harder ones, I'm not even sure how to with the formula in the place. So it's better to have thought of this also. Like if I didn't have that thing कि इतने किस बीच में ही होगा, I wouldn't have been able to just have a starting point only for this question. So yeah, I think not going into the formula, and for the harder ones, logic gives you a easier starting point. 100%.
And one thing you mentioned yesterday also, going through the answer choices also really helps.
Yes, that helped me in the gold bar wala question. That 96 hai, so it'll be up down. So yeah, I think all of these have been super helpful. As Kanav said, if you are planning on doing speed time, work rate, and others, happy to join those also subsequently.